Okay, we are given the diagram. We asked, what is the area of triangle QST? Okay, we're going to use 4 triangles to solve this. Triangle PQR, triangle QRT, triangle QST, and finally the largest, which is triangle PST. And we are going to use a theorem in similar triangle that states that the ratio of areas of 2 similar triangles is the same as the ratio of the squares of their corresponding sides. Yes. So if I call PQ, the height of PQ, let's call it H1, and the height of, that's triangle PQR, the height is that, and Y triangle XQT, let's call it H2. And you know this, the height of QST and the height of QRT are the same. They are the same. So let's call this, the area of this triangle, A1, though we are given 8 cm squared, but I'm trying to make it easier so that we'll solve direct. Let's call this A2, while this is A3. Do you get? The area of this one is although A1 is 8 cm squared, A2, that's what we are asked to find, while A3 is 12 cm squared. So we've known that the ratio of areas of 2 similar triangles is the same as the ratio of the squares of the corresponding sides. So I'm saying that triangle PQR is similar to that of, that's right triangle PQR is similar to PST. Triangle PXT. So which implies that the ratio of their area. So what's the area of this big triangle is A1 plus A2 plus A3. That's the area of the big one over the area of this, the PQR, which is A1, is the same as the ratio of the squares of their corresponding sides. So we're going to use height as the corresponding side. So for the big triangle is H1 plus H2 over H1. Do you get? This is a formula for ratio of areas of similar triangles. So it's a formula. So that's what you're going to use. And now you can see A1 divided by A1 is 1. A2 over A1 plus, so I divided A1, A2, and A3 by A1 equals 1 plus H2 over H1 all squared. Again, if you're asked to find the ratio of areas of 2 triangles with the same base, is the same as the ratio of their heights. Yes. Okay, let me zoom in. You are given, I should find area of this triangle. There's their ratio. I'm just taking any triangle. I know area is half base times height, but they have the same base. So here is also half A times H2. So if you notice that since they have the same base, the ratio of their area will be the same as the ratio of their heights. And again, if they have the same height, the ratio of their areas will be the same as the ratio of their bases. So that's what I'm going to use here. So see what I'm saying? I'm saying that is A2 over A1 plus A3 over A1 equals that H2 over H1 is the same as A3 over A1. Do you know why? Okay, let's go to the diagram. So if you, from what I just said now, you see that triangle PQR, that's triangle with area A1 and A3, have common base QR. So the ratio of the area is the same as the ratio of the height, but they gave us height here, so we can still replace it with area. You get the area is A3. So H2 over H1 is the same as A3 over A1. That was why I had to replace this with that. So let's now substitute the values. Remember, we're looking for A2. So we have 1 plus A2 over A1 is 8 plus A3 is 12 over, that's 12 over 8. This is 1 plus 12 over 8 all squared. And now you can see this is 1 plus A2 over 8 plus this is 3 over 2. That's 4 divided by 4. This is also 3 over 2 all squared. Okay, and you can see we are looking for A2. So A2 over 8 is now equal to 1 plus 3 over 2 is 5 over 2. So meaning that this one will go here to be minus 5 over 2. Why this is 5 over 2 squared? So 5 over 2 squared. Do you get? This is 5 over 2 squared, which is this. Why 1 plus 3 over 2 is also 5 over 2. Moving to that side is negative. And you can factor 5 over 2, remaining 5 over 2 here and 1 here. You get? They have 5 over 2 common. So bringing out 5 over 2, we are left with 5 over 2 here and 1 here. And this is 5 over 2 times 3 over 2. Yes. That's 2.5 minus 1 is 1.5, which is 3 over 2. So therefore, A2 we are looking for is 8 times 5 over 2 times 3 over 2. So this is 4 in 8. 2 times 3, 6. 6 times 5 is 30. So we have 30 cm squared. So the question is tricky. Just similar triangle and ratio of areas of triangles.